it's very important for you to remember that what we're looking for are places that there are discontinuities, or places where you just can't quite make the graph happen without picking up your pencil. So perhaps making the denominator 0, that's a huge problem. Sometimes they make the denominator and numerator 0 at the same time. Those are removable. But so far, for finding vertical, we set the bottom equal to 0. No big deal. But we've already, like we said there, discussed if the top and bottom are the same degree, correct? You know how to do those? And you also know what if the bottom's bigger. But obviously there is a possibility that the numerator is going to be bigger. And believe it or not, you might be surprised that that's split into two options. And the two options are basically, option 1, the top is exactly 1 degree bigger than the bottom. That can happen. An example of that could be something along those lines. Okay. So there's a good example of that. And it's very specific there. The word exactly is important. If that happens, we're going to get what's called a slant asymptote. So far we've only had vertical asymptotes, which obviously vertical means, you know, straight up and down like that. Well, maybe a little bit better than that. And horizontal asymptotes are those. So a slant asymptote is basically every other possibility of that line. Perhaps that slant asymptote does something like that, or maybe it goes through here like this. Okay, so there you can see why they came up with the name of a slant asymptote. It just has a tilt to it. It's not vertical or horizontal. So that's option 1. The top is exactly 1 bigger. Well, option 2 should be fairly obvious to figure out after that. Top is more than 1 bigger. Because aren't those, in essence, the two ways? Once you saw the first one, the second one should have been fairly easy to figure out. And a possible example of that could be, you know, maybe I have x to the third plus x minus 3 over x plus 22. Hopefully you agree that that numerator is more than 1 bigger than the denominator. And once again, hopefully you agree as x gets really big then, that numerator has a huge amount of power. In that case, whoops, this will not create a horizontal or a slant. You'll still have vertical, but there will be no horizontal or slant. The numerator is just too powerful. When it's only 1 bigger, it's not quite powerful enough. It's close, but not quite. And we already kind of talked about my definition of a slant asymptote there. A rational function. And I hope when I start saying those words, you start envisioning a variable in the denominator. So a rational function will have a slant if the numerator is exactly 1 greater than the denominator. Any questions? All right. So let's determine if the following functions have horizontal, vertical, and or slant asymptotes. Of course, what are we going to look out for first? Yeah. No matter what the directions, always look for holes first. Does it say look for holes? No. But they affect the problem, so you should look for them. How about letter A there? Should we be worried about anything canceling out and creating a hole? No. So at least that's nice, right? So now let's determine it. It's going to stay rational then, right? Nothing's going to happen. So is there going to be a vertical? Can I set the bottom equal to 0? Yes, I can I? So, and it just says determine if they have them. Does it say to find out what they are? No. So we would say that this one has a vertical asymptote because we would set that bottom equal to 0. Now our question is, it may or may not have a horizontal, it may or may not have a slant. But one thing that won't happen, it won't have a horizontal and a slant at the same time. So we have to take a look. Does it at least have one or the other, a horizontal or a slant? It does. Which one is this particular one going to have? I heard both answers of horizontal and slant. Why slant? Yeah, the numerator is exactly 1 degree bigger, correct? Do you know how to find out what it is yet? No, you don't. You'll find out. Okay? But we know it has a slant asymptote. So those are the two that it has. Letter B. What should we watch out for first again? Oh, yeah. Any shot at anything canceling off there? Nope. So is this going to have a vertical asymptote? I was being tricky. And you said x squared. What x value you can put in there that's going to make the bottom 0? I squared of 6? Yeah, I don't think we're going to worry about that one. How can you tell? Well, set it equal to 0. Subtract 6, subtract 6. Square root, square root. So can you set the bottom equal to 0? Yes, you can, but do you get anything that's real? No, they're imaginary. So there are no vertical asymptotes on this one, believe it or not. That's just me being tricky. We said there's no holes, there's no vertical. Can it still have a slant? Yeah, it can. Or a horizontal? Yes. Which one does it have? Slant. Top's one bigger. Letter C. Do we have to worry about anything canceling off? No. Now, some people say, well, can't that x squared cross off with that? Don't ever say that. Remember, if you're ever concerned about that, actually do a problem, you know. Let's just say x was 1. That's an easy one to do, right? If x was 1, that would be 1 plus 5 divided by, well, that's a bad example. Choose 2. You know, if you put a 2 in there, can you just start crossing things off? That'd be 16 plus 5 over 4. Can you just cross off a 4 from each one here? And you get the same answer? No, you don't get the same answer if you start crossing stuff off. Okay, and so you can't just cross those off. That's a good way to check if you ever get confused. So that one right there, is there going to be a vertical for that one then? Can I set the denominator equal to 0 and get an answer? Yeah, what makes the bottom 0? 0. So there is a vertical asymptote. We actually know what it is. It's 0. How about a horizontal? Well, for horizontal, they either have to be the same or the bottom bigger, right? Slant is, the top is 1 bigger. The top's 2 bigger. So, yeah, only vertical then. No horizontal, no slant. Well, you had to see this coming. What should we do first? Yeah, factor stuff out, look for holes. X in common.
Oh, baby. You think she's not good?
Have I factored that properly? Have I done anything wrong? No, I factored it right. Can I cross anything off? Can I, now that this is multiplication in here, can I cross? I can cross that with that. Now, do these directions say to find any holes? No, does this one have one? Yeah, but I don't have to write it down. I know that. Is -1 then guaranteed to be a vertical asymptote? Is -1 guaranteed to be a vertical asymptote? Not guaranteed. Could it be? Maybe. How would you tell if it's guaranteed? Well, look at your numerator now. Is it possible the numerator factors? Yeah, you got to factor it. Multiplies to be -4. Adds to be -3. Do such numbers exist? In all honesty, hopefully not in this case, because then we're almost done. But unfortunately, they are -4 and +1. Is that what it is? And so I'm going to speed things up if you don't mind. That's what the numerator factors to, is x minus 4 and x plus 1. Is -1 a vertical asymptote? Why not? Yeah, it cancels, exactly. It's out of there. So what's remaining after all of this is y equals, is the x minus 4 in the numerator or denominator? Numerator. Does that make a difference where you put it? Yeah, I think some of you learned that on that one assignment the other day, that yes, it does. So basically, you're being asked, does that right there have a vertical asymptote, horizontal and or slant asymptote? It's a line. Is that even rational anymore? So should you even be looking for asymptotes on that? No, it's not even, that doesn't have a variable on the bottom. So no, you shouldn't be looking. So does that one right there have a horizontal, vertical, and or slant? No, in fact, it has what? It has 2 holes. So does it have discontinuities? Yes, it does, but it doesn't have asymptotes. Okay. So I tried to trick you twice. Letter B, I tried to get you, and I kind of did. And letter D, maybe a little bit. Okay. But the key, always look for holes first. Any questions so far? Well, let's give one a shot. Determine all asymptotes and then sketch the graph. I think I can do that. Should we look for any holes? Well, of course you should. Are we going to find any? Anybody see any potential holes there? Anybody see any? No? All right. I don't see any either. Because some people might want to try and cross off all those x's, but that +1 stops you from doing that. All right? So no holes. That's awesome. So then we can start looking at asymptotes. Vertical asymptotes, all you have to do is set that denominator, because let's face it, dividing by 0 is not good. So let's find out what's going to make that happen. So you set the denominator, which is just x, right? You set it equal to 0 and solve. All right, I'm done. X equals 0 is a vertical asymptote. And there it is. Maybe coming soon. Oh, there it is. That's not very bright, is it? Oh, well. You can see it, can't you? Yeah. All right, so now that leads me to, is it a horizontal asymptote or a slant asymptote or none of the above? So we take a look. Well, horizontal are two options where they were the same power, right? Or the bottom was bigger. Those are your only two options for horizontal, and you got shortcuts for that, right? And we have the top is bigger. So then you have to decide, we know there's no horizontal. We have to decide if there's a slant or not. And there is. Awesome. Now, how do you find it? That's the tricky part. And the part that some of you are probably going to not like. To find the slant, you do what the problem says. It says to take this and divide it by that. So as somebody mumbled, long division, and you're right. Now this particular one's a monomial, so you could do it quicker. Monomial meaning only one term at the bottom. But this way works for all of them. All right, so this is why I'm going to do it this way. So this is how you find slants. So we'll make a little note over here. We got a slant. Everybody ready? So there's a 1 here and a 1 there, right? So you take x squared and you divide it by x. Well, what is that? X. Right? Because 1 divided by 1 is 1, and x squared divided by x is x. So you take x times x, you got to multiply back down now, is x squared. What's nice about this one is, remember, normally we have a binomial out here, don't we? So we have to multiply the x by that other thing too, but there is no other thing. Right? So that's why these are a little bit easier. So we're done doing all the multiplying. So now, don't forget, change your sign, right? Because then they go away, correct? If you don't change your sign, they don't go away. And now what? Yeah, bring down a term, and hopefully it helps. Plus x. Well, 0 plus x is just x. Can I take x, this one right here, and can I divide it by the x that's out here? Well, sure, it's 1, right? Understood, 1 there. Divided by 1 is 1. And x divided by x is also 1, isn't it? So 1 times 1 is 1. So you take 1 times x is x. Change sign. Hey, 0. How about that? Bring it down 1. So in other words, you agree the remainder is 1. Right? So it didn't divide out evenly. That's probably a good thing, because if it did divide out evenly, we forgot stuff that we could cross off. All right? Remember, see, if it divides evenly, it goes into it evenly, so we made a mistake somewhere. All right? So our remainder is really 1, and I'm still really trying to divide it by x, right? Here's the beauty of this. Make x really, really big. And if I put a really big number in there, it's 1 over something huge, correct? So that remainder is 1 over something really big, which is something really small. So here's something you're going to hear as math goes on. When you get slants, that remainder is what's called negligible. You don't have to worry about it. That's a real word. I'm not making that up to just make you cross off the remainder. So, boy, we did all this work, but boy, if you can't find where the slant is, that still doesn't help you. The answer is on there. X plus 1, exactly. It's whatever you just, it's right here. Okay? Y equals x plus 1. Now, it's an asymptote, and normally asymptotes are lines for at least our purposes. They aren't always. The more up in math you get, they become parabolas and whatnot. But that asymptote's a line, right? Could we graph that line? I sure hope you can all graph that line. And I hope you can graph it quicker. The y-intercept's 1, the slope's 1. Whoops. Agree that's where it is? I'm assuming you can all do that. You know, you are in advanced math, so I hope you can graph y equals x plus 1 without injuring yourself. Now, here's apparently where some of you are struggling a little bit. How do you figure out where the graph is? Well, if you have a vertical asymptote, choose something to the right of your vertical asymptote and choose something to the left. And find out, is it above the asymptote or below? That's all you got to do. So choosing 0 as an x value is a good example as a poor choice. So basically, we're making an xy table. If I were you, I would go back to the original. It's the safe place to go. So if my vertical is at x equals 0, choose something to the right. What x value is to the right of that? 1. So what you do is you put 1 back in the original. So you put 1 there, you put 1 there, and you put 1 there. Well, 1 squared is 1, plus another 1 is 2, plus another 1 is 3, divided by 1 is 3. So 1 comma 3, I hope you agree, is a point here. So you go over 1 and up 1, 2, 3. The point is right there. Right? And so I'm guessing the graph does something like that. Right? Goes towards the asymptotes. The asymptotes are pulling that graph in. Come on over. Now, there's no guarantee that the other graph is down in this bottom left-hand portion or the top left. You got to choose something over there. So choose something to the left of your vertical asymptote. What's a good choice? -1. All right. So put -1 in. But I got to take -1 and square it, and then -1 there and -1 there. So it's -1 squared. 1 minus 1, right? Plus 1. Do you agree that's what the top is? So those cancel, so it's 1, right? Over -1, which is -1. So -1, -1, there it is. And so it goes there, and it goes there. Again, these are just sketches. I want you to have some general idea of what they're doing. Rather interesting graph. Again, remember what you would really see is just that, if you graph it on a calculator. Again, the 83s do get a little confused, and they get down here and they just connect it to that point. because they really are unsure of what to do. Okay, so get used to what their graphs look like as well. Maybe as we get towards the end here, we'll actually graph one on the calculator so that you can see it. So are there any questions of anything that I did here? Is there anything surprising? Now, that's the first slant asymptote, so you can say yes if you want. Suggestions. Look for holes. Does it have a possibility? It does. Very slim, but then I've looked at things that can factor quite a bit more than you have. So if we're looking here, it has to multiply to be 1 and add to be 1. Multiply to be 1 and add to be 1, you need two numbers. Is 2 when you add. Is 0 when you add. And negative 1 when you multiply. I'm looking for two numbers that make that happen. They're either really bad radicals or imaginary. But we know for a fact x plus 2 is not one of the factors on the numerator. Agreed? It's either a radical or just, the numbers do exist, they're just horrible. And it's not x plus 2, and that's all we care about. So there's no hole, we don't have to worry about it. And so then we do, after we know that's the function that's left over. That's what remains. And so we can look for that vertical asymptote. In other words, what's going to make that denominator 0? Negative 2, right? If x equals negative 2, that thing's doomed. Because, obviously, you set it equal to 0, and you solve, right? Because sometimes they're harder than just looking at it and say, oh, negative 2. So, obviously, that's vertical, and so it's over here. So now we have to decide if we have a horizontal, a slant, or none of the above. And we take a look, and the numerator is exactly one more than the bottom. So we're guaranteed a slant. Don't forget all your horizontal rules, though. Those are if they're the same or the bottom's bigger. And everybody's favorite thing to do. But at least now you know in this particular problem, the remainder is what? No, not ineligible receiver downfield. It's negligible. Okay. All right. Here we go. 1x squared divided by 1x. Well, 1 divided by 1 is 1. X squared divided by x. X. Okay. This one's a little harder because it is a binomial out here. So you take x times x, that's x squared. But you also have to take x times the 2, right? This x has to go times that 2, and well, that's 2x. And here's where a lot of people do mess up. They have no trouble remembering that part. They change that sign, but they forget to change the other one. You have to change them all. You're subtracting all of it. And so you change that sign as well. So it is a 1x minus a 2x is a negative 1x, right? And now what you need to do, same thing you do almost all the time, you bring that down plus 1. So now I'm trying to take basically this negative 1 and I'm trying to divide it by this 1x that's up there. Well, negative 1 divided by 1 is negative 1. X divided by x is also 1, right? So it's negative 1 times 1 is negative 1. So negative 1 times x, negative 1x. Negative 1 times 2, though, don't forget that, is negative 2. Change your signs. And a big, it cancels, yay, and a big, who cares, it's a 3. Because that 3 is your, which is negligible. Because really it's remainder 3 over x plus 2, right? And that thing, who cares, all right? Because as x gets big, that thing's done anyways, so it doesn't matter. That thing's toast. So your slant is y equals x minus 1. Very good. Once again, I'm hoping that you are to the point where you can graph these lines quickly. Now, what did I tell you when looking for where those graphs go? just get some points. So pick something to the right of your vertical and to the left and find out where does it end up. What's the obvious choice for right of the asymptote? 0. Because where do you substitute all that stuff back in? I'd say the original. Because let's face it, if you mess up along the way and then you have some remaining bit and that's not right, and you start substituting things in there, you're going to get it wrong even more. So let's try 0. I like 0 because that's 0, and that's 0, and that's 0, so it's 1/2. 0, comma, 1/2. There it is. And so obviously here it is. Once again, there's no guarantee that it's on that bottom portion. I think it is again, but there's no guarantee. But you got to pick something to the left of your asymptote then. This choice isn't necessarily as obvious, but go, it's maybe, just -3, right? Might as well. So you got to put -3 in there, -3 in there, and -3 in there. But you got to take -3 and square it, which is 9 minus 3 plus 1 all over -1. Everybody agree with that? So 7 over -1, so -7. So I went to the left, -3, right? -3 is over here. -1, 2, 3, 4, 5, 6, 7. Please don't think they always do this, do top right and bottom left, because they don't. It is very possible it could be in here. Okay, it could be here. Don't always assume that they just do that. Question so far of why I do any parts of the step that I do. Not really. It's way less than having to take the inverse. Why don't you figure out the asymptotes for me? Take a second to do that. All right, let's take a look. First question, determine all holes. No holes, how come? Why? You can't cancel anything out. Okay, how about asymptotes? Well, can we set the denominator equal to 0? That means we get a vertical, correct? And it's at x equals -1, because that's what's going to make this bottom say 0. Is there anything else that'll make the bottom say 0? No, that's it, right? And you can always do that by just setting it equal to 0 and solving. As long as it's still there. So after you find holes, if it's still there, there you go. So we know x equals -1. There it is. Okay, now we have to decide, do we have a horizontal, a slant, or neither? Well, horizontal, remember, is if they're the same power or the bottom's bigger. And that's not happening here. The top's bigger. And if the top's exactly 1 bigger, you got a slant. The top here is, what's that mean? You have neither. There is no horizontal and there is no slant. So that's it. Awesome. I won't give you a whole lot of these because there's no other asymptote to pull your graph towards. And so how do you know what it's doing? And so this is one we'll just go ahead. We'll go let the graphing calculator take care of this one. And I'll show you a nice little, I've shown you the tool on there, but I don't know how many of you use it. So y equals, we don't need those, x to the third divided by, whoops. Be careful when you do divide like this, make sure you put it in parentheses, or it will only divide by the x and then add 1. I want to divide by all of it, correct? So put it in parentheses. And I have no clue what the window is set at, so we'll just zoom standard. Whoa. Is there still a vertical asymptote at x equals -1? Is it somewhat hard to see on here? It is, but if you just kind of grab this, there it is. And the one feature that you can use to help you out a lot, if you need to know some of these points, is the table. Okay. There they are. Oh, look at that. -1's an error. I wonder why. Because you're dividing by 0. Okay. And the one thing I found the other day that is kind of nice is, now I can't remember which one it is. I think it's that one. It just shows you all this stuff. That's kind of nice. Yeah, unfortunately, you don't have that button on your calculator. But you can see the points, and you can see the graph all at the same time. So it's, and the function. So that's kind of nice. Okay. Do you have any questions of what you've seen today? No?